So let's go ahead and get started. Your homework assignment. I just remembered that I forgot about something. Okay. So how many people try this out and got stuck at a certain point where, hey, it's giving me the error message over and over again. It's not moving forward. Okay. So that is, I admit it's a omission of my part. So I'm going to give you a part of that solution today. All right, so what we want to do is to kind of explain what Scanf is about first, because it is important to understand what Scanf is about. Scanf is not going to ask you until it gets the right thing. That is not what it does, okay? Okay, so this is something that you can kind of imagine in your mind. A file, standard in, standard out, all of those things are like conveyor belts, okay? I've used this analogy before, okay? So standard input, which is what Scanf uses for the input, is a conveyor belt coming your way. Okay, it's getting stuff from the keyboard in this case, and it's rolling those items your way, and you get to process those items one thing at a time. Are we doing okay so far with that analogy? So it's an input file, and the way you process an input file is one byte or one character at a time, and it's a conveyor belt. Now with Scanf, the %d that we specify is basically telling Scanf and say, okay, read the input file and get me an integer, a base 10 signed integer, which means it can be positive, it can be negative, but it has to be a base 10 number. Is that okay? So the %d is setting up an expectation of what to expect. This is what I want you to read for me. So with a conveyor belt analogy, it's kind of like someone is asking you to say, give me a red box out of the conveyor belt. But all you see is a blue box. What do? You don't do a single thing, right? Because a blue box does not match the description of what you're supposed to retrieve. So what you do is you tell the person who told you to retrieve a red box and say, I don't see a red box, so return 0. I did not remove a single thing from the conveyor belt. Is that okay? So what happens when that person asks you again and say, oh, go remove a red box from the conveyor belt? What is still on the conveyor belt?
Blue box.
The blue box. The blue box never moved. So if you keep asking Scanf to return an integer, to read an integer, and it is not an integer at the front of the conveyor belt, it will keep coming back and say, I cannot read a single thing. 0. Do you see what the problem is? Okay. So what we need is to find a way to clear the junk, okay, the invalid characters, until we get to a part where we can actually read an integer. That's what we need to do. Are there any questions about this part? First of all, I'm going to demonstrate, what the problem is, and then we'll go ahead and look at, a potential solution. There are several ways to do it, but we'll look at one solution. So I'll just call this program, scanf.cpp. I went through basically the same thing this morning, but I think this time I'll try a slightly different solution. So if you want to know the other solution, you can also watch the video for the early class, because they have a slightly different solution. So int x, and what we want to do is to reproduce the problem first. Okay, once we reproduce the problem, then we can try to find a solution. So the problem is, if I use just not scanf %d into %x, keep reading it. But this time I don't want to just keep reading it. I want to print an error message and say, give me an integer. That. And as soon as you give it an integer, it will. Well, let's go ahead and make some more code here. I'm sorry, for those of you who are copying, now you have to insert in your writing. Solving. Oh, did I record? Yep, I am recording. I'm just double checking. There we go. So I am recording, so if you don't want to spend your time copying all this stuff, you can just leave it the way it is. I'll give you guys some time to copy at least a part of it. So with this program, the intention of this program is, as long as I am not reading an integer, because if I'm not reading an integer, scanf returns a 0, and not 0 is true. So that means, I go into the body of this loop here. I will print one line of error message to remind the end user that I'm supposed to get an integer, and then I go back to this part here where it will try to read again. But this is not going to work, because if I input ASDF on the keyboard and then press the enter key, the lowercase a character is not the beginning of a base 10 number. So no matter how many times you tell scanf to reinterpret the input as a base 10 number, it will always fail. So in this case, this program will fail, as if I type ASDF, it will keep printing, give me an integer, because there's no way to get past the junk that is not an integer. Is that okay? All right. So the next thing we do is we'll give it a try. Okay. So we'll go ahead and g++-g-o scanf.cpp and run the program. It's asking me for an integer. Let's give it actual integers to process. 45. It says I just read 45, which is great. Okay. -3. Okay. It said I just read -3. ASDF. Now it keeps printing, give me an integer, and it wouldn't stop. Okay, just as expected, because as long as there's a blue box at the front of the conveyor belt, and scanf was asked to remove a red box, it will always come back and say I cannot remove a single thing, because it is not a red box at the beginning of the conveyor belt. That is the problem. So we need a mechanism where we can remove the quote-unquote junk out of standard int until we get to an integer, or the beginning of an actual integer. That's what we need to do. So the solution to this problem can also be done with scanf. The man page of scanf is really kind of long, but if you skip all the way to the part that is irrelevant, which is what is the letter after the percent mean, then we will see this part here. The following conversion specifiers are available. If you have a D following the percent symbol, it means we want to match an optionally signed decimal integer, which is base 10, and it can have a negative in front of it. The next pointer must be a pointer to an int integer. But that's not going to help us, because that's what we have in the original code. So we keep reading this until we find something that might be helpful. Uppercase D means equivalent to LD, which is basically a long decimal integer. In this case, it will try to read back a 64-bit integer. That's not going to help. I is optionally signed integer. The next pointer must be a pointer to int. The integer is read in base 16 if it begins with 0x, in base 8 if it begins with 0. That's not going to help. It is still a number. O is octal, it's a number, not going to help. U is unsigned decimal, it is still a number, it's not going to help. X is unsigned hexadecimal integer, which is also a number, not going to help. Same as lowercase x, not going to help. F is floating point number, it is still a number, not going to help. E is equivalent to F, G is equivalent to F, E is equivalent to F. A is equivalent to F under C99 standard. This may be helpful. Matches a sequence of non-white characters. The next pointer must be a pointer to a character array that is long enough to hold the input sequence and the terminating byte null byte. But have we talked about arrays yet in this class? No, so let's not use this solution.
What's a non-white space character?
A non-white space is anything other than space, tab, or carriage returned. So all the digits, all the punctuations, and special punctuations, they're all considered basically non-white characters. Let's try the next one. C matches a sequence of characters whose length is specified by the maximum field width, which has a default of 1. The next pointer must be a pointer to char, and there must be enough room for all the characters. The usual skip of leading white space is suppressed. This is our ticket. Okay, this is how we are going to fix this problem. Okay, so what I want to do is to kind of explain what a character is and why it relates to stuff that we have already talked about. How many of you still remember the type called int 8 underscore t? int 8 underscore t. What does that mean? It's an 8-bit signed integer. It can be positive or negative. What is a character? Is go ahead. I heard the right answer.
Anything, like a letter, number.
It can be a letter. Yep.
Can be space.
Any single thing. Okay. But how are bytes? I just answered my own question. I cannot have to stop doing that. Okay. What is a file, by the way? A file is a sequence of what? Bytes. Okay. And a character is essentially a byte. They're basically the same thing. It's just that in C and C++, we refer to it as a character, okay? But it is also a byte. It is also an 8-bit integer. So all of those things are essentially the same thing. A character, a byte, or an 8-bit integer, they're all basically the same thing. So with %C, we have the ability to read a single character. Whatever that character is, we can just read it in, and it will store the ASCII code of the character into a variable. So that's what it means by saying this. The next pointer must be a pointer to char, which is basically an 8-bit signed integer. So what we want to do now is to say, okay, that's great. So let's check out what this is going to do. So what we'll do is we'll write two programs, okay? One program is going to read using %d, and the other program is going to read using %c. Okay, so there's a %c and a %d, and we'll print out what it's reading in both cases. So we can now compare and contrast what does it mean when we say read a base 10 number as opposed to what reading in a character, because it can be confusing between those two. So this is a little digression, but it's a necessary digression to get this done. So here we have a simpler program to illustrate the concept of reading %d, which we pretty much know already. Okay, so this is not really a big deal. So we declare an integer x. We say scanf %d %x. And then we say printf. I just read %d, which is basically the same as the other program, so there's really no need to write this one down. It just reads one single integer, prints it out, and that's it. Doesn't do anything else. It doesn't. I don't even bother to check whether it read the number or not, because the whole point is, let's give it an actual number to read and see what happens. When you guys are ready, I'll move on. Since we have computers in front of you, all of you, you can actually use a computer to take notes too, if you want to.
I type really loud. I think it would be distracting.
Oh. Because you all have accounts to apps.losrios.edu. Start with Google Documents and just start typing. You cannot lose your notes that way. All right. So and then we'll copy this program to scan. FC, oops, cp scanfd.cpp and scanfc.cpp, and we'll change this program a little bit by changing it to a %c instead of a %d. Okay, so instead of writing everything down, you can just kind of say this program just changes the c to a d, it changes a d to a c. And we'll try to recompile the programs and see if it works. Okay. So here we go. G++-G-1 all -pedantic dash o scanfc scanfc.cpp, and guess what? It's going to complain. Well, what is it complaining about? It complains that in the scanf, %c expects an argument of type char pointer, but the argument is basically an integer pointer. Is that making any sense to you? Is the warning message making sense to you?
Yes, because when we are initializing variable x, we call it an integer. Is that what it's complaining about here?
Yeah, x is still an integer, just like before. But the use of x is incorrect in this context, because %c wants to read a character, and as a result, it wants a place that is of the type character to store what it has just read. Is that okay? No? Not okay?
Yeah. I understand what you're saying. So how do you fix it?
Well, there's one easy way to fix it. The easy way to fix it is to say, oh, you know what? X is not a typical type of integer. It is a 8-bit integer, which is basically the same thing as. You can use a char too, but since we haven't really used the word char in this class, I'm just going to say it's an 8-bit integer, which is the same thing as a character.
I was thinking originally that you would change it to char x, so I guess I did.
Yeah, char x would just fix the problem as well.
Okay.
Yep. But this will also. Yep.
Is there a reason we're not changing the %d to the %c in the print statement?
Aha. That's intentional. Because what I want to do is I want to print the value that I stored in x as a number, but not as a character. If I use %c in printf, then it will print the character itself. So if I type A, it will print A. If I type B, it will print B. But that's not what I want to do. I wanted to print the ASCII code of the character instead. And this is what this will do it. Okay? So are we good with this program so far? Okay? The fix is just changing the type to make the warning message go away. So let's go ahead and recompile the program, and this time it's clean. The other program should compile without any problem. So scanfd, which is the original one, would just compile without any problem. So now we can run both programs and look at the result and say, yeah, okay, they're different. So in this case, because I did not even bother to check whether scanf actually read a number or not, I probably should give it just a number, because otherwise it's meaningless. So let's say we give it like 5 as a number, press the enter key, and then what do you think it should do? This is scanfd, which is using %d for the scanf.
Should come back with 5.
It will say that it just read 5, right? And you're absolutely right. Okay, that's what we expect it to do. No problem here. What if we run scanfc and give it also 5 and then press the enter key?
It would be that I just read whatever the ASCII code is for 5.
Exactly. Okay, so what is the ASCII code of the digit 5? Tag, aren't they supposed to be the same? The ASCII code of 5 and the value 5, you know, 5 is 5, right? Well, that's what most people think the first time they encounter stuff like this, okay? 5 is a value, okay? 1, 2, 3, 4, 5. It's just a value. Okay? The digit 5 is not. The digit 5 is basically an 8-bit pattern that specifies, oh, you know what? I want you to print the digit 5 at the printer or on the screen, or when you press the key 5 on the keyboard, that's the code that is sent to your computer to store into a file. Which means the encoding of the digit 5 is not necessarily the value 5 itself. So in this case, the digit 5, which is a character, has an ASCII code of 53 in decimal, which doesn't seem to have anything to do with 5 itself, but it does.
When it returns 5, isn't it going in and looking for this code in order to it's basically like a chart, and you put it in there and it's like, oh, this represents this number or
exactly,
or letter or whatever it is that
yep, the bit pattern representing 53 in decimal is the 8-bit pattern to represent the digit 5 using ASCII. Is that part okay? Because this looks kind of strange. because it doesn't seem like 53 has anything to do with 5 other than it starts with a 5, but it doesn't seem to have anything to do with 5. To understand how it has relationship to 5 as a value, why the ASCII code of 5 is 53, you can do a man ASCII. It will bring up the manual page of ASCII code. So in this case, it explains what ASCII code is. It's American Standard Code for Information Interchange, which is one way of encoding characters into 8-bit patterns. This is not the only way. It is the popular way by today's standard, but it's not the only way. Those of you who have worked with mainframes, I don't think anyone here has touched mainframes. There's also another standard called EBCDIC. And EBCDIC has a different bit pattern to represent the digit 5. This is just one way to encode it. So the way we do it is the fourth column, by the way, okay, let me just scroll up a little bit here. The fourth column is the character, and then the second column is the ASCII code in decimal, because the ASCII code is really just an integer. So when we look up 5, which is here, we can see that this is the digit 5, and it has an ASCII code of 53 in decimal. But when you look at it as a hexadecimal number, it is 35. And that's where the 5 is. Now, how come in hexadecimal 35 is in decimal 53?
Different number system.
It's a different number system. In base 10, go ahead.
Oh, it's a different base. I mean,
It's a different base.
trying to go over every 10 instead of every 16.
Exactly. So 3 times 16 is 48. And then 48 plus 5 is 53. Okay? So that's why, the digit 5 actually has an ASCII code that has to do with 5 itself, it's just, except the base is off. It's not, from 5. Okay. So just looking back at the running of these two programs, do we have any questions about running scanfd and we are printing 5, but when we run scanfc using %c as the format string, we're getting 53 as the ASCII code of the character that we just read? Questions? No questions. Okay, if there are no questions, this is great, because now we can move forward and think of a solution to fix our original problem. So the original problem is, if we are not reading an integer into x, because the next letter, the next thing on the conveyor belt is not the beginning of a base 10 number, what are we going to do? We want to toss it away. Okay? We just want to grab whatever byte, whatever character it is, and say, let's throw it away. Move on to the next one. And how do we throw something away and move on to the next one? We just talked about it.
Scanf with the C.
Scanf with %c, exactly. Okay, so the way we do it is we can just put it here and say scanf with a %c, and where do we put it? We need a place to put it. And we know that this is not going to work because the compiler is going to warn about this and say, x is an integer. Now, I have a really dirty solution for this. I don't want to talk about dirty solutions in this class. In a more advanced class, it's okay, but in this class, it's not so good. So what I'll do is I'm just going to declare another variable, exactly. So this is an int8t, and we'll just call it junk, okay, because that's what it's going to store. But to do this, I have to pound include standard int.h. And then at this point, I'll just say, read the next character, but since it is just junk, put it into the junk variable, which is an 8-bit integer, also known as a character. Is that okay? Yep, go ahead.
This actually came up with my assignment, and the computer club Danny was telling me that he said something about a buffer, and I was wondering why doesn't with percent D or I or whichever wants to get like an integer value, why doesn't it read it and then throw an error that you didn't successfully read an integer that it read something else? Why
Because scanf doesn't want to move anything from the conveyor belt. it allows you to check, can I interpret what is at the front of the conveyor belt as an integer? If the answer is no, it's not going to take anything off of the conveyor belt, because you might want to do something with that quote-unquote junk, right? And that's why we need to use this way to say, okay, if it is not an integer, we want to remove all that junk until we can get to an integer.
I basically had that line in my code, and without that Scanf part, it just like
Yep.
infinite loops what you did.
Yep, that's what. Well, before you came here, that's what we
That's why we're talking.
demonstrated. Right, so let's go ahead and run this program and see what's going to happen. Yes?
Could we just use data type car instead of the date?
Yes, you can.
Same thing.
Same thing. All right, so let's go ahead and run this program and see what happens. But before we run it, we probably want to predict what it's going to do first. So, and we'll go ahead and run it. So this time I'm going to try ASDF 123 question mark a 12 and then press the enter key. And we want to figure out what the program is going to do when that's the input. And I can use a separate screen to look at the code. So let me just kind of move this out of the way and use another command line to look at the code. So just hold on 1 second here. There we go. So now we have the code and also the input, and we want to figure out what it's going to do. Okay, so at the very beginning, this is the front of the conveyor belt. Okay, we are reading from the beginning of the entire input, and that's when we encounter line 9 of the program. Line 9 of this program is saying, look at the front of the conveyor belt and get me a base 10 signed number. And we're looking at the lowercase a character here. Is that the beginning of a base 10 signed number? No. Line 9, the scanf of line 9, will come back and say, nope, that cannot possibly be an integer, so I'm going to return 0 because I cannot interpret what is at the front of standard in as an integer. What is not 0? Scanf returns 0, and then there's a negation in front of that, which means not 0. Not 0 is interpreted as true, okay? So true means we get into the loop here. So the next line is going to execute is going to be this line here. This line is telling scanf and say, just read me a character. Is lowercase a character? Yeah, everything is a character. That's kind of like the smallest unit you can read from any file. So anything can be read as a character. So surely we don't have a problem in this case. So lowercase a is going to be read as a character and stored in junk, which is an 8-bit integer. The ASCII code of a is stored in junk. And by the way, the ASCII code of a is 97 in decimal, or 61 in hexadecimal. And then it will print, give me an integer. And then at the end of the loop, it will go back to the beginning here. So it will call scanf again. But the second time we call scanf with a %d, the front of the conveyor belt is on the second character already. Is that the beginning of a base 10 number? Nope. So scanf with %d will fail again because we cannot look at lowercase s as the beginning of a base 10 number. So scanf on line 9 is going to return a 0, which means the negation of that is going to be true. So we come to this point again. So this time we read the lowercase s character into junk. Junk is going to have 100 and something because that's the ASCII code of lowercase s. And then we'll print another, give me an integer. So this code works by, when I say it works, I mean, it does move forward, okay? It doesn't get stuck and just get into an infinite loop. But there's a problem with this code. It prints one warning error message per character of junk that it reads, okay? Which is better than before, but yet it's not the best solution, okay? So I want to run this program and put a breakpoint on line 13 just so that we know what junk is, just to be consistent. Are we seeing what we should be seeing? But since the program is already in execution here, we'll just kind of finish it, and then we'll use GDB to debug this program. Okay, so you can see that it prints. Okay, let me pull this down a little bit. So it prints 4, give me an integer to correspond to ASDF, and then it prints 123 because that really is an integer. So it interprets those 3 characters as 123, read it into variable x, and then printed it out. And then it encountered a question mark, and that prompted this particular warning message. Then it encountered the second question mark and prompted the second error message, and then it read 1, 2, and it prints 1, 2. So that's the behavior of this program. We are close to a solution, but it's kind of naggy right now. It's nagging too much. Okay. All right. So if this program is sort of working, let's see if we can. I'm just going to go through GDB of the same program. Put a breakpoint, as I said, on line 13. Run the program. Give it ASDF 1, 2, 3 question mark 1, 2. Press the enter key. So now we are on line 13, which is right after Scanf Percency, and I want to see what is in junk. What do you think should be in junk at this point?
Question mark? Oh, actually.
The ASCII code of lowercase a.
Oh, we're at the beginning.
Right? So, yep. If I continue execution, it will read the second one. It will fail again, but this time what is in junk?
S or whatever it is.
Yep. It's 115 and so on. So this code is working, okay? Because what we're doing is, if we are not seeing what we're supposed to see, then we remove items from the conveyor belt of the smallest unit, one thing at a time, until we get to see the thing that we are expecting, which is a base 10 signed integer. Is that okay? All right. If that is okay, then we only have one problem to fix. The one problem that we have to fix, let me just make it kind of obvious what the problem is. What problem? 1, 2, 3. That is our problem. It's giving me one error message per character of junk. Okay.
Could you? This is just an idea. So could you remove what we're throwing away, the character, since we know that a non-numerical value is going to range from like whatever ASCII value it is, from like 97 to whatever, I think 123. So
Right.
could we just say while that one is in that range?
Nope. That won't work either. Because by the time you have taken something off of the conveyor belt, you cannot put it back onto the conveyor belt.
Oh, which would we like to check?
Yep.
Do you just want to know like how many?
How many?
What is your goal here? When you have it finished, do you want it to tell you how many didn't?
No, I just want to have
Then
one.
just get rid of that line.
I just want to have one warning
Right,
message.
like this, don't print it.
You can do that in the homework assignment because I did not say that you have to print an error message. However, if you do want to print an error message, but make it clean so it doesn't nag you all the time and say, okay, just give you one error message per chunk of erroneous characters.
Then
How
you
do we
can
do
just
it?
put like a counter, in there and its own little variable, so that it'll count up every time it has to skip
Okay.
over something.
That's
and then
good.
you drop your printf to the bottom, and then printf your whatever number has been dropped into your counter.
Okay, that's a very good starting point. Where do I declare the counter? Give me a line number.
Probably inside of the loop if you're only going to be using the loop.
Well, we got 2 loops.
Or between 10 and 11.
Between 10 and 11. Now, if
Oh
we,
no! Wait a minute. No.
No, you would.
No, but doesn't it?
Okay, let's see
Yeah.
what happens. Okay, if I put a counter here, what is the purpose of the counter?
Just to keep track of how many
It would
things
need
that
to-
aren't integers that it had to go back.
Okay, if we put it here, then we also have to do the initialization kind of in here as well,
Yeah.
in this block. And how do you want to initialize it?
At 0.
Okay, 0 seems to make sense,
Yeah.
right? And where do you want to increment it?
After you.
Now remember, by the time we get here, we already confirmed that there's junk on the conveyor belt.
Well, okay, so,
So should
then
you-
we'd actually start with 1, right? Because by entering into
You should never.
Yeah,
Should you start your? You should never start your counter.
yeah, so your initialization, you can't have it inside the loop, right?
Yeah, you-
Okay, so let's see what happens here. Okay, so with this code the way it is, the loop will still go through 4 times with ASDF. Does it make sense? Because in each iteration, it is removing 1 character of junk. But every time it re-enters the loop, it is re-declaring counter and re-initializing counter. So it's not
So it's
really
not gonna
doing the
work.
counting thing.
So you
That's
should-
an easy fix of this problem. Go ahead.
Line 14, instead of reading character, read string.
No, we don't want to deal with strings or arrays at this point.
Wouldn't you just initialize the counter before you got into this loop?
Yeah.
Yeah.
Something like here. That will do it.
Do that.
That will do it because this is declaring counter before the inner loop. The outer loop is not really that important. The outer loop is just saying keep reading forever. Okay, so because it's just an infinite loop. And by the way, this is the easiest way to, well, I guess it's not the easiest way, but it's one way to write an infinite loop. The other way to write an infinite loop is while 1. And I guess the 4-way saves you 1 character, so it is the shorter way. Okay, so this will fix the problem because now we declare the counter outside of the loop where the counting needs to happen. And we put the initialization also out of the loop where the counting is supposed to happen. Okay? So this is great. This is a very good beginning because now we can start to count the number of invalid characters that we have removed from the conveyor belt. And how is that going to help us? I know it's useful for something, but how is it going to help us?
That way we don't have to have the whole list of them and then count them, and it's a waste of computing something.
Exactly. So that means we can somehow use a condition to guard the printf statement here, and basically say we only want to do this once. But if it is the same sequence of invalid characters, we don't want to print anymore. So how do we say that? How do we say if this is the first invalid character, print the error message? What is keeping track of whether this is the first invalid character or not? Counter. Okay, so we know counter is involved here. And how do we use counter? If counter,
Zero. Well, yeah. Zero.
right? Because if counter equals to 0, and remember, we only increment counter at the end of each iteration. So if counter is 0 when we get to the conditional statement on line 15, that means this is the first time of this entire chunk of invalid characters. This is the first one. So print an error message. But when you encounter the second one, the third one, and so on, counter is no longer 0 because it will be 1, 2, 3, and so on. So it will suppress the warning messages for the other ones. So this is our ticket. This is the way out of this particular problem here. So we'll go ahead. I'll let you guys have a little bit of time to copy something down first. All right, let me know when we are ready to move on.
You can go ahead.
All right, so I'll just go ahead and write it here, and then on the other side I can recompile the program, so I can do both at the same time. Right, so this time when we run the program, I'll give it exactly the same input as before, which is ASDF 123 question mark 1 2, and then press the enter key. And what do you think should happen this time with the guarding of the warning message, error messages.
Here it says one. Give me just one time. It'll say give me an integer. Then it'll say I just read 1, 2, 3, and then
And then give me an
Another
integer.
error message, and then 1, 2, 12, and then it will prompt me again. That's exactly it. And you can lift this code and put it into your program directly. It is a little bit tricky, because you have to. If you don't want any error messages, it's easy because it won't, give you the messages all the time. But if you wanted to print the error message, you have to kind of, it's a little bit tricky. Using the counter concept is the trickiest part of it. Yep.
I do apologize for showing the play because this might be a repeat. But for when it's not in a loop, Scanf returns. So for one of the issues is like what happens when you're asking for like max entries and they give another error. They give like another character. When I ran,
You don't have to worry about that. When you are asking for the number of entries or the threshold, there's no need to do error checking. The error checking only applies to the entries.
But just for discussion, it pulls back. It'll pull an integer, or it'll interpret that character as an integer. Like when I ran through.
No, it does not interpret a character as an integer. It will stop. It will basically just come. It will refuse to read anything because it doesn't match the pattern that you're specifying.
Oh, that must be okay. That must be the uninitialized value that I'm seeing. Like when you run GDB and you print the value of that variable.
Now, how many people know about subroutines and stuff like that? You can turn this into a subroutine. Then every time you want to read a base 10 signed integer, call the subroutine, and when it returns, it has to be the right thing. So that's one thing you can do. Then you can do error checking for everything. Every time you want a base 10 signed number, you're always doing it right. Yep.
So when you scan a number and assign it to the pointer, does it overwrite the variable each time, or does it append it?
Say that again, please.
So say you've got two integers that come in, 1, 2, 3, and 1, 2, or something like that. Does the 12 overwrite the 123?
Yes. Now, when you input two numbers, you have to space out the two with something in between. So you can use a space, which is okay. This is not going to trigger a error message because Scanf automatically has the ability to skip over empty space. So this is not going to be a problem. Space is not going to be a problem. The tab character is not going to be a problem. The line feed character is not going to be a problem because those are called space characters, because they are all used for one single purpose, to separate items. So this is not going to be a problem. It will read 123, put it into X, print the value 123. I just read 123. Go back to try to read another base 10 number. But when it tries to read a base 10 number and it encounters a space character, it automatically skips the space character. And the same thing applies to the tab character, because those things are considered white space characters and they are not interfering with the reading of numbers. So just to verify that, you can see that there's no error message this time. On the other hand, if you use a comma, which to human beings is a very natural thing to do to separate numbers, right? But since it is not a white space character, it's going to cause an issue. So this time it will give you one error message, because when it tries to read the comma, it is not considered a number, it's not a digit, and yet it is not a white space character either. Very good questions. Yep.
What's the point of the MD4 statement?
This one here?
Yeah.
Just so that I don't have to rerun the program every single time. Because otherwise, every time I press the enter key, this will also read multiple integers. If I remove the forever here, it will only attempt to read one character, so I can't really show you how the error processing logic works. Yep.
So it reads that second set of question marks as give me an integer, but if we initialize the counter to 0 and then we incremented it by 1 after that first, so the ASDF will give us our first give me an integer.
Correct.
And then
Yeah, when it parsed, well, actually, when it parsed the A, it will give you the error message. Then it will silently, take these three away from the conveyor belt, because at that time, counter is no longer 0, so it will suppress the error message for the other 3 characters.
Well, that's my question. Then when we get to question mark, how come we get another error message?
Because of this.
Because it got out of the loop.
Because when you get out of the loop, we go back to the beginning of the outer loop, and that before we get back into the inner loop, it reinitializes counter to 0.
Okay.
It resets the whole thing.
Now, I don't think, and I apologize if we have, but
No, go ahead.
When you start putting in like pound include, you just kind of nonchalantly threw that up there, and like I still have no idea what's going on with the include or like the beginning of the program.
Okay.
But
That's a very good question. That's definitely not a problem. The pound include, when you see pound include something, it is basically taking the file standard.io.h, which is sitting in a folder somewhere, but GCC magically knows where to find that file, and it will basically include the content of that text file as if it is a part of this program.
okay.
Now, standard.io contains the prototype definitions of scanf as well as printf. So without pound including standard.io.h, the compiler will complain about scanf and printf because nobody told the compiler how to make use of printf and scanf. Like, for the first parameter, it has to be a string, but nobody told me that, so I cannot do any error checking, and the compiler kind of freaks out about that. The same thing applies to int 8_t. This one here. This is actually not a built-in type of C++, and it is actually defined in standard int.h, stdint.h. So that's why the other one is also needed.
And so like you said before about just making it char
Correct.
John, instead you wouldn't have had to include stdint.
That is correct.
Okay.
Yep.
And how or where do we need to go, or what do we need to know as far as those particular files and what they're available for? Because if we're writing, we need to know that something needs to be imported from one of these files. If we don't know, we keep getting that error message.
That is
but we
true.
don't know how to fix it.
I kind of sprinkle those things, around a little bit, so it's a little bit hard to spot. But they are there somewhere. I know they're there because these are important things, and I know that I put it there, but it's not necessarily at an easy place to find. So when we get to types, I think this is where we see the stdint, standard int. And this one. Sorry, when I do this, I know it's kind of confusing from your perspective.
It's whenever you tell us to use like int 32 and 16.
Integer types of C++, I think that must be it. Sounds like it, smells like it.
It's just kind. I think we ever talked about.
Yep. Yep. I kind of sprinkle these things around, when it is the right context. I kind of mention it, at a certain point. So, and this is a whole explanation of why do we even bother with, using, integers like this, which specify 32-bit width here. This is 16-bit width. This is 8-bit width, and
I guess I'm more interested in the files themselves and like what's in them, like what files are there.
I think
It's
he
like an
means
additional
more-
toolbox. It seems that I have no idea about what's going on over there.
I see what he's saying.
Huh?
You gotta have a Linux machine because in the Windows you won't be able to. See those files.
no. There are ways to look it up.
Like you go to like the C++ reference that you gave us.
Well, let me see. Okay, I'm gonna see if I can answer that question. So let me see if I can find that. Nope. If you look it up on the, if you start with this and try to find the include file that defines it, that is not too hard because Google can help you with that. But to know that you can actually use something like this to begin with, that is harder.
And that's kind
These-
of what I meant.
it's going to be this. That's kind of like the content of this class, so I will be kind of sprinkling those things, as
Okay.
as the class moves on. But by itself, it's not a very useful topic. So if I just kind of say, okay, in today's class we'll talk about standard in.h and what it includes, it's not going to be very useful because I will certainly forget 95% of that class without the context to make use of those things. And that's why in the notes here there's a context to use it, because it has to do with we're dealing with integers here. And I explained what the problem was is sometimes if you just use the word int, then it's platform dependent. On some platforms int is 32-bit, on other platforms it's 64-bit. So if you write a program that's compiled just fine and it runs just fine with a 64-bit platform, and you take exactly the same program, recompile it on the 32-bit platform, it may not work because integers on a 32-bit platform is 32-bit wide. That's just int itself. So your program is not going to work because the platform has changed. But if you use these words, use these types instead, then you're forcing a particular type to be 64-bit, 32-bit, 16-bit, or 8-bit. So the same program can be recompiled on any platform and it should still work the same way. So that's the context of why we need stuff like that, and I try to make it kind of like more like context sensitive.
I got all that, and I remember us covering all it. It's just the pound include sitting at the top. I had no idea really where it was, what's involved, and why it's being.
Okay. Is it better now?
Yeah.
Okay, excellent. All
Roll.
right. Good.
Roll.
Oh, I'm not taking roll today. All right. But thanks for the reminder. All right. So is that helping with your homework assignment? Okay, very good. Yeah, Scanf is pretty useful. So we'll go back. Oh, there's one more thing. Question 1 and question 2 of the exam 1 are graded. They don't have an entry by themselves, so when you look up your grade book, they are basically by themselves, as quote unquote assignments, okay? In the assigned quote unquote assignment itself, you will find the grade using what I call a grading guide, and you will find out, for each item, what is the standard to get 1 out of 3, 2 out of 3, and 3 out of 3 points, and and you will see the mark that you're getting for each item of the question in the test.
Are they only 3 points apiece questions?
No. They're
just an
they're all
example?
weighted equally. So together, the 4 questions will make up 20% of your final grade, which means each question makes up 5% of your final grade. But to make marking easy, sometimes I scale it to a different number. Like for the first question, I scale it to 11 points.
Okay.
But the 11 points for question 1 really shrinks to 25% of your first exam or 5% of your final grade. So the scaling is not factored in when you just look at the assignment itself. Yep.
This is away from this. I saw it you wanted to talk about this,
No,
but
go ahead.
the last week I had asked why they chose to use cint as a variable as opposed to subroutine like with printf, and you said there was an answer, and I don't know if we actually went over it.
Oh, okay. Let's go to that question. But let me see if there are any additional questions here before we go back to file operations. So are there any questions about your score for exam 1, question 1? If it is individual, don't ask that question here. On the other hand, if you cannot see it at all, then it's a problem, because if you cannot see it, most of your other classmates probably cannot see it either. So is anyone having issues with at least getting to the grade? If you do not agree with the grade, that's a separate issue, and we can talk about it separately.
Are you going to have the rest of it graded this week then?
Yep, soon. The first one turned out to be the hardest one to grade because I kind of merged 2 questions into one, whether there's a syntax problem, and if not, tell me what to do to get to a certain line. So that makes it kind of hard to grade because I want to give partial credit for people who say there's a syntax error. So instead of giving all of those people saying you get 0 because you got the first part of the question wrong. So that took me a while to figure out, how to kind of do it fairly. Because some people say, there's a syntax error, but what they really meant is there's a logic error. And so for those people, I still give them partial credit because they can analyze the code correctly and say, okay, it's not a syntax issue. It's just that some people were pretty smart. They figure out that there's a way to bypass all the code. Because if v1 equals to v2, then it won't match the first condition nor the second. And they classify it as a syntax error, which it is not. So it's a logic issue. It's not a syntax error, and there's no. I did not even state what the program is supposed to do to begin with, so there's no right or wrong to begin with. So for those people, I don't want to just say, oh, you got this wrong and give you a 0 for the whole thing. So I had to come up with a better way to give partial credit for the first question. So what I'll do is I'm going to pass the exam back to you guys, and with your permission, I will just kind of hand it back and let you guys pass it around. There are no numbers, no grade, no comments whatsoever on the paper themselves. Because the grade is on Moodle itself. So is there any objection of me passing the exam with no score whatsoever around?
I object. I'm just kidding.
So I'll separate it into 2 piles.
Mine's at the very top right there.
Oh, lucky you. There you go. And if you have any questions about it, we can talk about it. I do have to leave by 2:30. So if you have some really pressing question, you can ask me by email. I have a photocopy of everything, as I said. I unstaple every single one, run it through the scanner, and then restaple everything. And then I grade it based on the scanned sample. Sorry? There's a lot of wasted steel on the staples. But I do have a very good de-stapler. The ones that you can buy 2 of them for $1 at the Dollar Tree, those work really well. My favorite store. Yes? Let me see if I can do that without disclosing the grade of one of you, because that would not be cool. The district will be on me right away. It's like, Tack, you're not supposed to do that. So I'm going to add myself as a student to this class if I'm not already one. I might have. No, I have removed all the non-actual students in the class. So I'm going to re-add myself. And this is CISP.
I think you still have my more operators wrong quiz in the grade book as well. Remember when I sent you the email?
Yeah, I will fix that.
Oh, okay.
Yeah.
I was just checking.
Yep. What is the enrollment key of this class? Does anyone remember?
Oh, I might have it written down. The enrollment key?
Yeah, the enrollment key.
I had it.
I think it has something to do with Unix.
Yeah, it's Unix for all, right?
Yeah, Unix for all, I think sounds right.
Unix for all?
Yeah.
Okay. Yay, I'm in class. Okay, so if I go to grades, I should see. I do not see it because I haven't graded my own exam yet. Okay, so let me see if I can let me see if I can do that without disclosing the grades of everybody else. Okay. Okay, I know what to do. I have to turn off the screen for a while I do this part. Ah, that's right. I will have to probably just cut out that part from the recording, or separate the recording into 2 parts.
did I. I got 45% of it.
Yay. Okay. So as it turns out, I did not have to disclose the grade of anyone else. So I'm gonna turn the screen back on, and there's nothing to edit out of the recording either. Okay, so here's my own grade. I'm gonna put a grade into my own
Did you give yourself
account
an A?
here.
You should have.
So I'm gonna say, 1, 0, 2, and another 0 here. Some people got 1 point dinged of these two parts here because line 9 is still reachable in the program, in the code. Even though I only asked, how did we get to line 6 or line 8, line 9 is still reachable. So that's why, some people got 1 point dinged, because of that. So anyway, let me click Save Changes. All right, so now I can go to the other browser as a student and update it, see if I can find my grade. Is that what you guys are seeing? You're not seeing anything?
No, I see my grade.
You saw yours? Okay. Did you go to the grade book?
I went to the left side.
The assignment itself?
where it says-
Well,
Okay.
no, I went to the left side.
Oh,
that
I
said
know why.
grades.
Because I haven't done the syllabus acknowledgement. Okay. I have to reattempt because, once I kick myself out of the class, I have to redo it again. Great. But I do have to answer this correctly, otherwise I cannot get to my grade book. All you have to do is to find the answer with do not and to pick the other one, right? Oh, not this one. I choose to ignore the prerequisite. Kick me out of the class, please. Alrighty. So submit all and finish. Now I should see everything that I'm supposed to. Okay, there we go. Go back to the class. Go to my grade book. Oh, I got all the way out.
But no.
Alright, go back to the grade book. Much better. Seeing a lot more stuff. So I got 27.27% out of the whole thing. So if I click on the homework assignment, it will give me more information. And this is what you should be seeing too, kind of. Is that right?
Mm-hmm.
Okay, so what you're seeing here is, this is the question itself, the out of this part, it doesn't show you the total amount of points that you can get. Out of this one, it is 2 points. If you do not say, did I say?
Next mark. Two.
Right underneath.
Oh, maximum mark. Okay, that's good. But what is my actual point?
Down. You gotta go below. In the feedback.
Oh, okay, there we go. Okay, so the feedback is this part here. I got 1 out of 2 out of this one here. And I got 0 out of 3 out of this one, which is the first part, assuming there's no syntax error of the trace. I got 2 out of 3 here, and I got 0 out of 3 here. With most people who got something wrong, I would also leave a feedback of why I took 1 or 2 points off. So that's what you should be seeing.
Are you sure? Because I had some where there was something missing off of it and it didn't have any feedback on it.
Okay, I can explain that if you are curious. Yep. So for those of you who want a better explanation of why points were deducted or why points were not deducted, never got one of those questions, but if you have a question about that, I can answer that too.
No, it's wrong. I'm sure. I'm not gonna argue about that.
Well, when should we expect grades on the other two programs?
Sometime this week.
Okay.
Yep. Won't be long. Any other questions about your grade?
Actually, not necessarily the grade, but maybe the way you maybe wrote question 1 a little bit. Having us pick our numbers instead of you telling us what to use. Was there a reason behind that? Just curious. I found it harder to try and pick the right
To look
number.
at the table.
Yeah.
It's just to kind of randomize things a little bit, in case you have a curious neighbor, not implying
I don't
any
have
one of your
curiosity, not
actual
that kind of
neighbors.
way.
I saw you looking at me.
No. But I have cases like that. In one of my classes, which is also an introduction to programming kind of class, I got one guy who turned around to look at
No,
the
he
person
didn't.
behind him, which is very ineffective because he would have to read upside down, which is not really the best way to do things. So even if I were even if I were to walk out of the classroom, that would not be a very efficient way of looking at somebody else's work.
A little obvious. Too.
Maybe, just maybe, that student behind him was particularly good at the subject matter, so it's a reliable source of information. I don't know, but it was odd. It was very odd.
It's pretty ballsy, actually. I'm just gonna turn around.
Just stretching, yeah. I need to, fix my neck muscle or something. Yeah.
Just to see if we can get an answer before we leave about the variable.
The variable? Oh, cin. Yes. Very good. All right. So the question is, what exactly is cin? So if you use cin to read something into X, this is the way you do it. Okay. So the question now is, how do we call cin? And what is that greater than symbol? How do we call that? Okay. So in this case, cin is actually a variable. It is the name of a variable which is of the type input stream or iStream. Okay. So if this is a variable, just like X, Y, or Z, what exactly is this? How do we call that? It is an operator. Okay, so in terms of classification, it is the same thing as a plus, a minus, a multiplication, a slash, which is a division. It's in the same class. This is actually usually called what we call the right shift operator. Okay, greater than is a right shift operator. But in the context of using cin or a input stream, it is an operator to specify what are we reading into, and that becomes the third item of this line. So is that answering your question?
No, it's not so much of the use, but of the purpose of why go from the method that we talked about where you're
Because it is object oriented.
and that
okay.
kind of helps like abstract or something.
Okay, so let's compare these two items here, because they do about the same thing, but they're not exactly the same. Okay, this is the C++ way to do it. There is no way to do this in regular C, because regular C has no cin. It doesn't have the concept of an input stream in regular C. This way is called the C method. It is just regular C, and it will work in both C and C++ environments. Okay. In the first case, you don't see any parentheses. Without any parentheses, it cannot be a function. So it is the name of a variable. In the second case, Scanf is the name of a function. And with any function, even if there are no parameters, you still have to specify the pair of parentheses. And the reason why this works is because cin is using object-oriented programming methods, where they can redefine an operator to mean something other than its natural meaning. Because right shift has a natural meaning of shifting bit positions in an integer. But by using the operator overload feature of C++, they can redefine the right shift operator to mean something else. So in this case, the right shift operator is actually sensitive to what is on the right hand side. If on the right hand side you have an integer, it reads an integer. If it is a character, it reads a character. If it's a float, it reads a float. It is actually type sensitive because each one has its own corresponding function in C++ programming. Now that's going way too far into actual C++ programming, so I'll just kind of stop here. But that is what you're looking into.
So, well, we can stop there. But if we threw that into the while statement, that wouldn't occur the same way.
No, it won't do the same thing because it does not return what you want it to return.
Oh, it stores it.
Yeah, cin does not return. Okay, this operator, this expression, this is an expression. Okay, because it's an operator and it has two numbers or two things to work on. So by itself, it is an expression. So every expression returns something, right? But it does not return the number of items that it correctly parses. What it returns is cin itself.
It returns a variable.
No, cin.
Oh, right.
It returns cin itself so that you can read multiple items just by doing it like this. This will read into X and then read into Y and then read into Z. And the way it works is because it groups the operators this way. Now, because you asked the question, so I feel kind of obligated to answer that one. It's because the right shift operator is what we call left associative. So without using your own parentheses to specify anything, it naturally wants to group it this way. As I said a little bit earlier, this one has the side effect of reading something into X, but at the same time, the expression itself returns cin. So that means the left-hand side of this operator is really just cin.
Oh, so Y gets whatever.
Y gets whatever that I type in after X, and then this whole thing is also just returning cin. And that's what I'm going to use to read into Z.
So with the conveyor belt analogy, it returns back an empty conveyor belt each time.
Correct. Which is kind of a weird concept, but that's what it does. So in C++, there's actually no easy way to do error checking that we did.
Yeah. So you literally couldn't throw cin into a while statement the way we do a scanf because
it's not that easy.
It's not a numerical
It's not
value.
that easy because in C++, when there's something other than what you expect that should happens, then they usually handle it by the concept of an exception. So the code that is seeing something that is unexpected will throw an exception. So the code that is actually trying to do something that can cause a problem can either leave it the way it is, and then the exception goes all the way out of the program, so your program just quote-unquote crashes. Or it can have a catch statement to basically say, if something unexpected happens, this is how we want to catch that exception and then do something about it. So it gets a little bit more complicated, whereas in C, you get a code back, you get information back right away and say, oh, you asked me to read a signed integer, I could not read one, and then you can decide what to do, which in some ways is easier to do certain things. Now, before we end today's class, I still have 40 seconds or so.
Thank you, Claire.
I do want to emphasize one thing. The one thing I want to emphasize once we find the file is right here. If you look at this file here, without error checking, it's just one single scanf, right? In other words, just line 11, even without a while, is all that you need. If you know that your input data can be trusted and there's no error whatsoever. Is that making any sense?
Yes, but if you're trying to trust a user to put things in,
Yes.
that's not safe.
And this is why programs are huge. Because of error checking.
That makes sense.
Because we have to include error checking, that one single line of line 11 is now much bigger.
Because you can't control what your user's going to do. You just have to plan for the worst and hope for the best.
Well, you don't hope at all.
You just don't care.
There's no,
Assume they will.
yeah,
Assume
there's
they're
no,
gonna do it wrong.
assume they will go wrong, exactly. And sometimes, even with your best ability to anticipate what can possibly go wrong, some users are much better at that
making
type of thing than
errors.
you are. because, well, I would just say non-programmer type, okay? The fact that you're already in this class means that you already know something about logic, and this type of thing does not bother you. And you are not likely to do certain things that are completely illogical, even if you try. And then there are end users out there that can do it without even trying. The first time they run your program, they break it. It's like, how did you break that? I was trying to break my own program for an entire week and I could not do it. And they
why you
sit down and go like, oh, your program's broken.
That's why you shouldn't test your own program.
Exactly. That is
Because you're not